Dear all, welcome to another exciting video. Today's topic is AC induction motors. Induction motors are the widely used motors all around the world. This machine plays a very important role in industrial world. Conversion of electrical energy to mechanical energy is taking place in the motor. There are induction motors which work with single-phase and three-phase. Motors used in home appliances like fan, washing machine etc. are single-phase induction motor. Other motors used in industries are mostly three-phase induction motors. We are going to see the basic working of the most widely used induction motor, the three-phase induction motor. As these motors are the widely used ones, the major share of power produced all around the world is being consumed by motors. Now we'll see the working of a three-phase induction motor. The major parts of a motor are stator and rotor. The three-phase electric supply is connected to the stator winding. When the supply is given to the stator, it will create a magnetic field inside the stator. Physically the stator is stationary, but due to the peculiarity of the three-phase electricity, the magnetic field created in the stator is rotating in nature. This rotating field creates a virtual magnet rotating effect. The rotor of the three-phase induction motor is kept inside the stator. During starting, the rotor is at steady state condition, which is staying within a rotating magnetic field. As per Faraday's law of electromagnetic induction, the rotating magnetic field around the rotor induces an EMF on the rotor bars. And as per Lenz's law, the EMF inducted in a conductor will oppose the cause of production of the EMF. Here in our case, the EMF was induced on rotor, due to the rotating magnetic field. And the reason for the induction of EMF on the rotor is the relative movement between the rotor and the rotating field. To reduce the relative motion between the rotating magnetic field produced by the stator and rotor, the rotor also should move along with the stator rotating field. This causes the rotor to rotate. The force on the rotor bars which causes the rotation is proportional to the magnetic flux density, current on the rotor bar and the length of the rotor bar. As we discussed previously, the current induced on the rotor bar depends on the relative speed between rotating magnetic field and the rotor. When there is a load applied on the rotor speed reduces. Correspondingly, the relative speed between rotor and the magnetic field increases, which cause more EMF to get generated on the rotor conductor, resulting on more rotor current and more force. Thus the motor again exerts more force to keep the relative speed to minimum by taking more electric power. Three-phase induction motors are most common in today's world. This is because of their rugged construction and wide range of applications. Depending upon the type of application, induction motors varies in size and ratings ranging from few watts to several megawatts. So today we have covered the elementary basics of the operating principle of a three-phase induction motor. Post your valuable comments. Thank you.